Hello everyone, this is Naira Zaid from Periodontology and Oral Microbiology, Catholic University of Leuven. I would like to communicate with you today about one of our interesting research questions. Are chlorhexidine mouth rinses all acting the same towards oral biofilms? A study that has been published in the Journal of Periodontal Research. As well known in dentistry, chlorhexidine is the gold standard for oral antiseptics and mouth rinse products to control the oral plaque biofilms, which include different oral bacteria. One important fact about chlorhexidine is that it is a universal antimicrobial agent, affecting mostly all of the oral bacteria without differentiating between the oral commensals or pathogens. The balance between both communities is crucial for the oral health. If the commensals are dominating in the oral biofilms, a state of symbiosis is reaching, which is the desired health state for the oral cavity and now has been a target for many oral treatments. However, if the pathogens dominate the oral biofilms, a state of dysbiosis is reaching, which is well reported to potentiate more inflammatory response and worsen the prognosis of oral conditions. The antimicrobial activity of chlorhexidine increases with increasing the concentrations of chlorhexidine, but also are the side effects. Higher chlorhexidine concentrations are often limited to short-term use with low patient compliance, while for long-term use, products with lower concentrations were preferred, which necessitates combining with other antiseptics to have a comparable effect. From a pharmaceutical aspect, formulating a mouth rinse product requires combining with many other ingredients before it can be introduced for market use. All of the listed additives could possibly alter the antimicrobial properties of chlorhexidine towards the total bacterial community in general or towards one of the subcommunities, the commensals or the pathogens, and so affecting the ecology and the balance of the oral microbiome. Here started our research question. Are chlorhexidine mouth rinses all acting the same towards oral biofilms? And to find the answer to this question, we tested 9 different mouth rinse products in the market. The tested products were grouped into 3 groups according to their chlorhexidine concentration, to low, medium, and high concentration groups. Multi-species oral communities were grown in a bioreactor with 6 oral pathogens and 8 commensal species. To simulate the biofilm formation on tooth surface, biofilm were grown from these communities on the surface of hydroxyapatite discs. The biofilms on the disc surfaces were rinsed with the corresponding products for 3 days, and the biofilms were analyzed using bacterial DNA extractions and qPCR analysis. 3 effects were observed. 1 product didn't have any significant differences than the negative control rinse, 4 products showed delayed effect, and 4 products had a strong effect observed after the first rinse. But what are the changes happening in the biofilm composition with the mouth rinse products? We analyzed the changes in the subcommunities, commensals, and pathogens individually. For the control biofilms, the growth in the 2 subcommunities went in parallel with the commensals dominating the biofilms and keeping the symbiosis of the community. This was also the case with 4 products, which caused parallel changes in the 2 subcommunities and maintained the biofilm symbiosis. However, on the other hand, the rest of the products caused harmful effect to the commensal subcommunity more than the pathogens, and so the biofilms got dysbiotic. If we bring all the observations together, it would be better to regroup the tested products regardless of their composition, but more depending on their effect on the rinsed biofilms. If we look to the effect on the total bacterial load, we can conclude that group 3 includes the best products to use. However, with next level analysis that goes beyond the biofilm quantity and include the biofilm quality, we get a more clear overview about the biofilm changes happening with rinsing. So finally, we could find the answer to our research question. Are chlorhexidine mouth rinses all acting the same towards oral biofilms? And the answer was simply no. Not all chlorhexidine mouth rinses have the same effect on oral biofilms, and there was no relation between the chlorhexidine concentration, presence or absence of other antiseptics, and the observed effects. Some chlorhexidine products that strongly lowered the biofilm quantity disrupted the biofilm symbiosis. the other hand, other products with limited impact on biofilm quantity improve the biofilm ecology and community structure. So we recommend that the product selection is better to depend on the indication and the clinical assessment. If a strong effect is needed, in case of pre or post-operative care for example, it's better to consider the biofilm quantity, while for long-term control, it's better to consider more the biofilm ecology and symbiose. And at the end of this video abstract, I would like to thank you all for your interest in oral research, wishing you the best oral health ever.